Hi, welcome back to Unit 1. This is Section 5, Lesson 1, and the first video for this lesson. This is Ms. Clemens-Brenton, and in this video we'll look at the Pythagorean theorem. The Pythagoras theorem is said to get its name from Pythagoras of Samos, a Greek mathematician and philosopher who lived during 6th century BC. Though the theorem was named after Pythagoras, historians have found evidence of its use by ancient Babylonians more than 1,000 years earlier. In ancient Egypt, the rope stretchers, similar to modern-day surveyors, used the Pythagoras theorem when constructing the pyramids. The rope stretchers used ropes in a 3-4-5 formation when constructing building foundations. This is what formed the basis for the geometric relationship that we know today as the Pythagoras theorem. The ropes used by the rope stretchers had 12 evenly spaced knots. When the ropes were pegged to the ground in a pattern as shown, a right triangle would result. The side opposite the right angle, the longest side, is called the hypotenuse, while the two shorter sides that form the right angle are called legs. Pythagoras noticed a unique pattern in these 3-4-5 triangles and demonstrated the relationship geometrically. When squares were constructed on each side of the right triangle, he noticed a special relationship. He noticed that the sum of the area of the two smaller squares was equal to the area of the larger square. So if this leg is A and this leg is B, and we call the hypotenuse C, then the area of this square would be A squared, the area of this square would be B squared, and the area of this square would be C squared. This relationship can be summarized by the equation A squared plus B squared equals C squared. Example 1. Find the missing area. So if we applied what we just learned, the Pythagoras theorem tells us that the area of the two smaller squares, so the A square plus the B square, will give us the area of the larger square. So if I look at this diagram, I can see that I'm given the area of the two smaller squares because those are the squares that are on the legs. The 90-degree angle is between those two sides. So if I add 16 to 45, I will get 61. So that means the area of this square here is 61 meters squared. In example B, again, Pythagoras' theorem tells us that the area of the two smaller squares adds together to give us the area of the bigger square. So when I look at this particular diagram, I can see that I'm given the area of the larger square because the larger square is on the hypotenuse across from the 90-degree angle. So in order to find the area of this square here, the area that's missing, we would need to subtract these two areas. So 92 subtract 54 gives me 38. So the area then of this small green square is 38 centimeters squared. Example C. In this case, they're not giving us a diagram, but they're telling us that the A square is 50, B squared is 18, and we're looking for the C square. So remember, the Pythagoras theorem tells us that the A square plus the B square, or A squared plus B squared, is equal to C squared. So that means 50 plus 18 will give me C squared. So 50 plus 18 gives me 68, and you have to make sure you write in units. In this case, we don't have any, so it's just 68, and that is C squared. Example D, we're told that B squared is 32, C squared is 120, and we're looking for A squared. So again, the Pythagoras theorem tells us that A squared plus B squared is equal to C squared. So in this case, we're looking for A squared. So something plus 32 is going to give me 120. So if I need to find A squared, then I'm going to have to do the inverse operation, and I'm going to have to subtract 32 from 120. So 120 minus 32 gives me 88. So that means A squared is equal to 88. Example 2. Find the missing side length. So in looking at this diagram, they're giving us the area of the big square, and we have one other square, so one of the squares on the legs. So if we remember, the Pythagoras theorem tells us that the area of the two smaller squares, so the A squared plus the B squared, is equal to C squared. So in this case, I'll call this square here the A squared. I'll call this square here B squared, and we'll call this side C squared. So 36 plus B squared is equal to 100. And if I'm looking for b squared, I know 36 plus something gives me 100. So I have to subtract. 100 minus 36 will give me b squared. And 100 minus 36 gives me 64. And in this case, we're talking about meters squared. So 64 meters squared is equal to b squared. So that's the area of this square right here, 64 meters squared. But remember, this question is not asking us for the area of the square. This question is asking for the side length. They're asking for x. So remember, to find the side length of a square, if we know the area, we take the square root of the area. So that means we take the square root of 64. The square root of 64, if you remember, 8 times 8 gives me 64. So the square root of 64 is 8. And in this case, we're talking about meters, so it's 8 meters. So the side of the square is 8 meters. Example B. So they're giving me a triangle here, and they're giving me the side lengths of this triangle. They're not telling me the areas. In the other diagram, we knew that we had areas because number one, the diagram was drawn that way. And secondly, they're showing us the units squared. So this meter squared indicates that the area was given. Over here, it's just 12 centimeters, so that's not area. So I actually have to square these measures first. So remember, Pythagoras' theorem tells us that the a square plus the b square is equal to the c square. So what that means is the area of the two smaller squares gives us the area of the bigger square. So when I look at this triangle, I have to figure out what measures I'm given. Well, here's the 90-degree angle. Across from that 90-degree angle, they've indicated that it's 12 centimeters. So that means this is the hypotenuse. The hypotenuse is always c in our equation. So I'm going to plug these numbers in. So let's say that this is a. Let's say that this side is b. Then that means 5 squared plus x squared is equal to 12 squared. So if I found the square over here, if the side is 5, the square of this side would be 25. So 5 squared is 25, plus this square, we don't know what that is yet, so plus the x square or the b square is equal to, this side over here is 12, and the square on that side would be 144. So again, 25 plus something gives me 144. If I want to figure out what x squared is, I have to do the inverse operation. So 144 subtract 25 will give me x squared. So when I subtract 25 from 144, I get 119. So that's equal to x squared. But remember, they're not asking us to find the area of that square. They're asking us to find the side length. And to find the side length, we always do the square root of the area. So that means I would take the square root of 119. Remember, to estimate the square roots, we find the two perfect squares that are located around 119. So the perfect square just above would be 121. The perfect square just below would be 100. The square root of 100 is 10, and the square root of 121 is 11. And I know 119 is 2 away from 121 and 19 away from 100. So that means it's really close to 121. So if I'm looking for a number between 10 and 11, and it's going to be really close to 11, I would probably say 10.9. So that means the side length here would be 10.9 centimeters. Example C. They're not giving us a diagram. They're just telling us that A is equal to 6, B is equal to 4, and we're looking for C. So again, the Pythagoras theorem tells us that a squared plus b squared, which means the square on the two smaller sides of a right triangle, is equal to c squared, which is equal to the hypotenuse squared. So if I take a and plug it in, I get 6 squared. And if I plug in b, which is 4 squared, that should give me c squared. So 6 squared, 6 times 6 is 36. 4 squared, that's 4 times 4, which is 16. Add those together, and I should get c squared. So 36 plus 16 gives me 52. 52 is the square. It's c squared. We don't want the square. We want the side length. So to find the side length, I square root the area. So if I square root 52, and I estimate that, then the two perfect squares around 52 are 49 and 64. The square root of 49 is 7. The square root of 64 is 8. 49 is only 3 numbers away from 52, and it's 12 away from 64. So that means if I'm picking a number between 7 and 8, it's going to be much closer to 7. So I would say approximately 7.2. There are no units on this one, so C in this case is simply 7.2. Please complete the activities for this lesson.